Welcome back. In the last video, we put a real website live on its own domain, but that site was static, it just sat there. Today, we make it come alive. We are going to build a real working contact form and behind it, a proper serverless API on Amazon Web Services, your AWS. When someone fills in the form, their message will travel through an API into a function and get saved in a real cloud database with no servers for us to manage at all. This is the single most valuable skill on a cloud channel, turning a static page into a full stack app. I explain every step on the real console and the real command line in order. Let's build. Here is what we are building, working right now on vnlabs.com. This is a real contact form. I type a name, an email, and a message. I press send and watch it says, "Thanks, your message was saved." That message just traveled from the browser to an API to a function into a database in the cloud and came back in under a second, and we never touched a server. By the end of this video, you will have built this exact thing. Let me show you the 4 pieces that make it work. Here is the plan in order. 1. A database to store the messages using DynamoDB. 2. A function that saves a message using AWS Lambda. 3. A secure permission, an IAM role, so the function can only do that one thing. 4. A public web address for it using API Gateway. Then we handled a famous browser gotcha called CORS, wire up the form on our site, and deploy it with the same automatic pipeline from last time. 4 pieces, 1 serverless API. Let's start with the database. First, what does serverless even mean? It does not mean there are no servers. It means you never see them, never patch them, never pay for them sitting idle. You just hand AWS your code and your data, and it runs them on demand, and you pay only when they are actually used. For our data, the perfect serverless database is DynamoDB. It is a key-value database, incredibly fast, and it scales itself. Watch the command. I run AWS DynamoDB create table, I name it vnlabs contacts, I give it a single key called ID, and crucially, I set the billing mode to pay per request. That last part is what makes it serverless. We pay per write, not per hour. In a few seconds, the table is active. We now have a place to store every message. Let's see that exact table in the AWS console so you know where it lives. This is DynamoDB, and here is our table, vnlabs contacts. Right now, it is empty. We have not saved anything yet. Notice there is no server, no capacity to choose, no maintenance. It is just a table that is ready and waiting. The scan button reads everything in the table. We will come back to it at the end to prove our messages landed here. For now, an empty serverless database ready to go. Next, the function, the actual logic that saves a message. This runs on AWS Lambda. A Lambda function is just a small piece of code that AWS runs for you whenever it is triggered, and you pay per run in milliseconds. Our function does one simple job. Watch the code, it reads the name, email, and message from the request. It checks they are not empty, it generates a unique ID, and it saves one item into our DynamoDB table. But here's the security part that real engineers care about. Before the function can touch the database, it needs permission, and we give it the least possible. Watch, I create an IAM role, and I attach a policy that allows exactly one action, DynamoDB PTT a PTT on exactly one table, ours, and nothing else. If this function were ever hacked, that is all it could do, write a contact message. Then I zip the code and create the function with AWS Lambda create function, attaching that role. The function is live. Let's look at that permission in the console, because least privilege is the most important security habit in the cloud. This is our IAM role, and these are its permissions. 1, the basic logging permission, so the function can write its logs. And 2, our custom policy, and if you read it, it allows a single action, DynamoDB PP item, on a single resource, our vnlabs contacts table. That is it. No read, no delete, no other table, no other service. This is least privilege. Give every piece of your system the smallest set of permissions it needs to do its job, and nothing more. And here is the function itself in the Lambda console. Look at the overview diagram at the top. You can already see the shape of our API, an API gateway trigger on the left, pointing into our function. Below, in the code editor, is the exact handler we just wrote. It imports the AWS library, reads the incoming message, and calls put item to save it. This is the entire backend logic, a few lines running with no server. Now we need to give it a public address, so the form can reach it. A Lambda function on its own is private, the internet cannot call it. To give it a public, secure web address, we put API gateway in front of it. A PI gateway is the front door to your serverless API. It receives requests from the internet and routes them to your function. Watch the commands. I create an HTTP API, then I create an integration that connects it to our Lambda. Then I create a route, the line that matters, post/contact. This says, when a POST request comes into the contact path, send it to our function. I deploy it to a default stage that auto-updates, and I give API gateway permission to invoke the Lambda. Out comes a real public HTTPS endpoint. Our backend is now reachable from anywhere. Here is that API in the console. Under routes, you can see exactly what we built, a single route, post/contact, attached to our Lambda function as its integration. This is the public door to our serverless backend. Anything that sends a POST to this address, with a name, email, and message, will trigger our function and save a row. Clean and minimal, we only opened the one route we need. Now, the single most common thing that breaks a project like this, and I promised you will hit it, CORS, cross-origin resource sharing. Here is the problem. Our website lives at vnlabs.com, but our API lives at a different AWS address. For security, browsers block a page on one address from calling a different address. Unless that other address explicitly says, it is okay, I allow you. CORS is how the API gives that permission. On this screen, we configure it. We set allow origins to our website, vnlabs.com, we allow the POST method, and we allow the content type header. Without this, the form would fail with a confusing CORS error in the browser console, the number one beginner trap. With it, the browser is happy. So if your API ever works in a command line test but fails from the browser, it is almost always this. Before we touch the website, let's prove the backend works on its own from the command line. Watch, I use curl to send a POST request straight to our endpoint with a test name, email, and message in JSON. And it comes straight back, HTTP 200. Oh, true, thanks. Your message was saved. Then I send a bad request with a missing field, and it correctly refuses. With a 400 error, our validation works. Finally, I run a scan on the DynamoDB table from the command line, and there is our test message sitting in the database. The whole backend, API to function to database, worked perfectly. Now let's connect the website. And here is the proof in the console, the same table that was empty a few minutes ago. Now, when I scan it, there are our messages, each one a row, with the unique ID we generated, the time it was created, and the name, email, and message the user sent. This is real data, saved by our serverless API, with no server running in between. Every form submission from now on becomes a row, right here. The last piece is the website itself. I add a simple form to our page, 3 fields, name, email, and message, and a small piece of JavaScript that, when you press send, packages those fields and posts them to our API endpoint, then shows the response. That is the only front-end code we need. And to ship it, remember our pipeline from last time? I do not upload anything by hand. I just commit and git push, and our GitHub Actions pipeline automatically deploys the new page to S3 and refreshes CloudFront. A minute later, the live site has the form. Now the real test, the whole thing end-to-end in a real browser. I open vnlabs.com, I fill in the form, a name, an email, a message, and I press send. And there it is, thanks, your message was saved. That worked from the browser across 2 different addresses, which means our CORS is correct. And if we look back in DynamoDB, that message is now a new row. Take a second to appreciate the path. The browser, to API gateway to a Lambda function, into DynamoDB, and back, all serverless, all on our own domain, costing essentially nothing when idle. Your website is now full stack. Let's lock it in order. 1. DynamoDB gives us a fast, serverless database with no servers to manage. 2. A Lambda function holds our logic and runs only when called. 3. An IAM role gives that function the least privilege it needs. 1 action, 1 table. 4. AP. A gateway gives it a public, secure web address. 5. CORS is the browser permission that lets our site call that API, the gotcha to always remember. And our existing CI/CD pipeline ships the whole thing with 1 git push. And here's why this matters. A static site shows information, but a serverless API lets your site do things, save data, take payments, send email, power an app. This exact pattern, API Gateway, Lambda, and DynamoDB, is one of the most in-demand skills in cloud engineering, and you just built it on your own domain. I'm Vion. Now go make yours dynamic, and I will see you in the next one.